Hi, my name is Anthony Peters, and today I'm going to talk to you about my project proposal, Environmentally Adaptive Cruise Control for Autonomous Vehicles. So, as today's autonomous vehicles are being put on the road, the algorithms that are implemented inside these vehicles don't take into account the comfort or safety of the passenger. They're very robotic in nature, and they jerk as they follow their driving trajectory. So some previous work that has been done before to solve this problem has been done by Way and others, where they produce a simulation of a vehicle on a road implementing nonlinear model predictive control, and they sought to optimize the control algorithm to achieve a smooth and comfortable trajectory while applying trajectory constraints using a defined safety corridor. So they limited the steering angle that the car can go under while also limiting the acceleration and jerk that the car was producing under that trajectory. Some other work was done by Tang, Zhu, and Ma, where they defined a comfort function underneath a action boundary for the autonomous vehicle to operate under. They found that the comfort level of the vehicle was a significant thing to consider while making an autonomous vehicle autonomous. However, the comfort boundary was a direct trade-off to the stability tracking problem, and the low amount of acceleration and jerk led the car to a slow tracking algorithm. Other work was done by Kabahani and Bashash, where they directly chose a kinematic vehicle model versus the dynamic vehicle model to simplify its algorithms and implementation into low computational computers. The objective of this proposed project is to implement cruise control within a robotic autonomous vehicle kit that adapts driving behavior to road conditions and dynamics. The autonomous vehicle will be able to recognize the obscurities on the road and the road's turn radius and adapt its driving behavior safely. The major deliverables of this project are a small-scale autonomous vehicle and an indoor test track environment, a written protocol for autonomous vehicle to complete a turn aligned with the defined safe human driving behavior, and computer simulations and control algorithms for the safe handling and driving of the vehicle. The evaluation metrics of this project are achieving a 98% speed tracking accuracy on an obstacle-free straight road, maintaining at most 15% departure from the road's center during turns, and achieving above 90% success rate of obscurities within the road with sensor detection. The way that this project will be approached is first choosing and assembling a small-scale autonomous vehicle and making an indoor test track environment for it. Next, we'll be making the computer simulations and the control algorithms that will show the safe handling and driving for the vehicle. And then lastly, there will be a written protocol for the autonomous vehicle to complete a turn aligned with a defined safe human driving behavior. Some risks associated with this project include the image processing algorithm speed. If the data is unable to be processed very rapidly, it can introduce delays in the system, resulting in an incorrect control input for the car and a low tracking accuracy. This can be prevented by implementing a Kalman filter, which takes in the vehicle's dynamics with equations while also taking real-time sensor input and taking the difference between the two and averaging them out to make correct data. Another risk to this project is the inaccurate object detection or misinterpretation of visual cues. Insufficient lighting within the car's environment can lead to a lot of sensor noise, A way to prevent this sensor noise is to add a LED light underneath the camera and filter out unneeded noise for correct object detection. Some preliminary work that has already been done is first selecting the car itself and assembling it. 2, with the help of Kabahani and Bashash, formulating the lateral vehicle dynamics. And then 3, implementing the lateral vehicle dynamics inside of MATLAB and simulating a PID controller for it. This project is significant because today's autonomous vehicles are unoptimized and not trusted by the passenger. If they're not trusted by the passenger, then the consumer will never adopt them, and it won't lead to the benefits that autonomous driving has, which is a safer road for everybody. Thank you.